Okay, this is the problem which is given in GATE 2015. The problem statement is that if input x of t and output y of t of an LTI system are related by the differential equation y double dash of t minus y dash of t minus 6y of t is equal to x of t. If system is neither causal nor stable, then impulse response h of t of the system is. Now we have to find the unit impulse response of that system. First of all, we find the transfer function of that system. How do you find the transfer function of that system? Here the differential equation is given. You write the differential equation. Y double dash of t minus y dash of t minus 6y of t is equal to x of t. Is equal to x of t. Then you apply the Laplace transform on both sides. You apply the Laplace transform on both sides. The Laplace transform of y double dash of t, that is d square y of t by dt square, is equal to s square y of s. Assume that initial conditions are 0, because initial conditions are not given. You can assume that initial conditions are 0. Then the Laplace transform of dy by dt is equal to s into y of s minus 6 into y of s is equal to x of s. You take the common of y of s here is equal to s square minus s minus 6 is equal to x of s. Then y of s by x of s. Y of s by x of s. Of course, this is the transfer function of the system. H of s is equal to 1 by s square minus s minus 6. Okay. Now you can write this expression. You take the factors. This is equal to s minus 3 into s plus 2. Okay. Now you write this expression as a by s minus 3 plus b by s plus 2. B by s plus 2. Now how do you find the value of a? A is equal to 1 by s square s, right, s minus 3 into s plus 2. You multiply with s minus 3 here and you substitute s. If s minus 3 is equal to 0, s is equal to 3. Before substituting, you cancel s minus 3. If you substitute s is equal to 3, this is equal to 1 by 5. Similarly, b is equal to 1 by, same, you write the same expression, 1 by s minus 3 into s plus 2 into, you have to multiply with the b is related with s plus 2 now. You multiply with s plus 2 and s is equal to minus 2. You make s plus 2 is equal to 0, s is equal to minus 2. Then if you substitute, this is equal to minus 1 by 5. Minus 1 by 5. So x of s is equal to x of s is equal to x of s is equal to 1 by 5 by s minus 3 plus b is equal to minus 1 by 5 now, minus 1 by 5 s plus 2, s plus 2. So not the x of s, h of s. The inverse Laplace transform of h of s is equal to unit impulse response h of t. H of t. H of t is equal to inverse Laplace transform of 1 by 5 s minus 3 minus 1 by 5 s plus 2. Okay. Now what we have discussed previously, the Laplace transform of e to the power of minus at e of t is equal to Laplace transform of this is equal to 1 by s plus a, and ROC is equal to sigma is greater than minus a. And similarly minus e to the power of minus at e of minus t. Simply you put minus sign here, minus sign here. Minus minus, then the Laplace transform is same 1 by s plus a, but sigma is less than minus a. Sigma is less than minus a because of this e of minus t. Okay. Now, what is the inverse Laplace transform of 1 by s minus 3? Whether inverse Laplace transform of 1 by s minus 3 is a right-sided signal or left-sided signal. Similarly, what is the inverse Laplace transform of 1 by s plus 2? Whether it is a right-sided signal or left-sided signal. That information is not given. That information is not given. But one information is given. That is, the system is neither causal nor stable. Neither causal nor stable. It is not stable, and as well as it is not causal. If it is not stable, means the ROC of that signal, h of t, the ROC of h of s definitely does not include j omega axis. Definitely does not include j omega axis. Okay. Because of this condition, the ROC does not include j omega axis. Next, it is not causal. It is not causal means the ROC definitely not right-sided. Definitely not right-sided. Okay. So, definitely not right-sided. First of all, we indicate the poles for the signal. S is equal to 3 and S is equal to minus 2. S is equal to 3, there is a pole. S is equal to minus 2, there is a pole. Okay. So, first we find the inverse Laplace transform for this 1 by 5 divided by s minus 3. What is the inverse Laplace transform? The inverse Laplace transform of 1 by 5 divided by s minus 3. There are two possible answers. One possible answer is that 1 by 5. You take this formula. 1 by 5 e to the power of 3t. Why 3? Because s minus 3 is there. A is equal to minus 3. So minus into minus plus e to the power of 3t e of t. Maybe this or 1 by 5 e to the power of 3t by taking this answer. Minus 1 by 5 e to the power of 3t e of minus t. Okay. If you consider this as the answer, what is the ROC? Sigma is greater than minus 3. If you consider this as the answer, what is the ROC? Sigma is less than minus 3. Sigma is less than minus 3. Not minus 3, sorry, 3. Because there is a pole at S is equal to 3. Okay. If sigma is less than 3, then ROC will be like this. The ROC will be like this. If sigma is greater than 3, the ROC is like this. Okay, the ROC is like this. Okay. Again, now we find the for the second signal, that is 1 by 5 divided by s plus 2. The inverse Laplace transform of 1 by 5 s plus 2 is equal to two answers. One is that 1 by 5 into e to the power of minus 2t e of t, and the second answer is that 1 by 5 e to the power of minus 2t e of minus t, minus 1 by 5. If you consider this as the answer, what is the ROC? Sigma is greater than minus 2. If you consider this as the answer, sigma is less than minus 2. So, if sigma is greater than minus 2, This is the ROC. Sigma is less than minus 2. This is the ROC. Here 4 ROCs are there. 2 ROCs are related to this, and these 2 ROCs are related to this. And out of these two, which one is considered, and out of these two, which one is considered? That is the problem. So whatever it may be, 4 combinations will become this one and this one, this one, this one, this one, this one, this. 4 combinations. Out of 4 combinations, which 4 combination is perfectly suitable? That you have to decide by using this condition. This is neither causal nor stable. So okay. So suppose if I consider this as the and this one, these two cases, then there is no common ROC. The Laplace transform does not exist. So it is not working. And this one and this one and this one and this one. This is not okay. These two. If you consider these two, then common ROC becomes ROC sigma is greater than 3. Sigma is greater than 3, and it is not including the j omega axis. It is not including the j omega axis. So it is working. It is working. Okay. So one condition is that you take the sigma is greater than 3, and the second one is sigma is greater than minus 2. Sigma is greater than minus 2. So that is no. It is not causal. No, it is not. If you consider these two also, then it is not including j omega axis, but it is in the right side. So it is also not working. So that is also not working. And now you take this one and this one. Both are left-sided. Both are left-sided. Suppose it is left-sided and you take these two. Then if you take these two, then you will get ROC between minus 2 to plus 3. Then it includes the j omega axis. It includes the j omega axis. So in this case also, it is not working. So the final option is that you take this one and you take this one. Both are left-sided. Both are left-sided. This one and this one. This one, this one. So the final answer is that h of t is equal to if you take this one minus 1 by 5 e to the power of 3t e of minus t, and you take this one minus into minus plus 1 by 5 e to the power of minus 2t e of minus t. So this is the answer. Thank you.